I'm going to introduce now my good colleague, Joe Ackroyd. Joe Ackroyd is the Director of Engineering and Deputy Floodplain Administrator at the Technical Affairs Division of the New York City Department of Buildings. As the Deputy Floodplain Administrator for the Community of New York, Mr. Ackroyd provides technical and administrative support on all issues related to floodplain management. As technical advisor for current code revision cycle, he was extensively involved in revisions to flood-related design provisions and foundation design provisions of the New York City Building Code. Prior to working for the Department of Buildings, Mr. Ackroyd worked for the MTA and private engineering firms as a geotechnical engineer, specializing in geotechnical design, geotechnical investigations, and construction inspection. Mr. Ackroyd received a Bachelor of Science in Civil Engineering from the University of Rhode Island and Master of Science in Civil Engineering from the New Jersey Institute of Technology. Mr. Ackroyd is a licensed professional engineer in the state of New York. He is also the father of two, including baby Alice, born just last week. So thanks to his family for letting him come and visit us today.
I was having a discussion with my wife and my daughter explaining how important a milestone the birthing of a new code is. I guess my wife didn't quite get it, but my daughter did. I think I was the slowest one to get my PowerPoint slide up. Okay, real quickly, for those of you that decided to take a look at Local Law 141 for Chapter 18, you would have noticed that the entire chapter is underlined, and Helen went into great detail about underlining being new text, brackets being deletions. But the case here is that Chapter 18 was one of the few chapters that really didn't conform to the IBC model. And so the committee did its best to amend Chapter 18, relocate sections, and it was so extensive that it was decided to repeal and replace that entire chapter. So that's why when you look at 141, you'll see so much underlining for Chapter 18. And I'm actually going to start with a section that was deleted, a section that was removed. As Gus previously mentioned, BC 1618 covers the load on temporary installations. Also, the soil and foundation panel drafted a new section for temporary supportive excavation, which I'll cover in a second. But this particular section didn't pass their scrutiny. They thought that maybe it was being used in manners that it shouldn't, so it was removed. This particular section dealt with designs using allowable working stresses for load reductions, and basically temporary structures were permitted for load combinations in equation 16.8, 16.9 can be multiplied by a factor of 0.75. Additionally, equation 16.10, 16.11, 16.12 multiplied by a factor of 0.67. So this section no longer lives on. And if you didn't get it now, the big X should be clear. Additionally, with this section, dead load combinations with 3 or more variable loads. Variable loads can be multiplied by a factor of 0.67. Load combinations used in the design of permanent structures, lateral earth and groundwater pressures. Loads multiplied by a factor of 1. This 2 is gone. And a new section, BC 1806.3, which is more specific to temporary retaining structures, supportive excavations, things like that. These particular types of structures, the structural members for temporary retaining structures may be designed with a 20% decrease in computed bending moment only. So I think this is a good compromise. Delving into the definition section of BC 1801.3, there were a lot of new definitions added to clarify either new sections that were added or just to add clarity to the code. Free and fixed-headed piles, there's a new definition for. Shallow foundations, there's a new definition for. Underpinning, waterproofing, retaining walls, helical piles, geotechnical capacity of deep foundations, liquefaction, and piers. So I'll go into greater detail on some of these definitions, but not all. A couple of definitions were amended. Specifically, driven uncased piles was amended to clarify that these particular types of piles are prohibited for use in New York City. The committee felt as though the type of installation couldn't guarantee construction quality, and it's our understanding that they're not used widely in New York City, so these are now prohibited. And micropiles, the definition was amended to specify a minimum diameter. There was a lot of questions about the minimum diameter of micropiles, and that's been clarified. So with regard to subsurface explorations, there were, in the 2008 code, it was a little unclear how to deal with certain types of alterations to buildings with regard to subsurface explorations. So new structures, it's pretty clear you're required to do a subsurface exploration. Horizontal enlargements, now it's explicit that subsurface explorations are required, or investigations. However, vertical enlargements or alterations with new foundations or added loads that exceed 5% of existing design capacity, now we're explicitly stating that a subsurface investigation is required to verify that the subsurface and soils are adequate for those increased loads. This table is illustrating the difference between the 2008 New York City Building Code and the 2014 New York City Building Code scoping section, the number of borings required. This particular table is dealing with non-pile supported structures only, and when we're talking about the number of borings, it's a built over area that we're using, so basically the footprint of the building. So you can see that for small buildings, 750 square foot footprint, one boring is required per the 2014 code, where 2 borings is required for the 2008 New York City Building Code. Pretty much once you exceed 750 square feet, there's really no difference. Another note, retaining walls with a height that exceeds 10 feet are required 1 boring for every 50 linear feet. This is a clarification that was not in the 2008 New York City Building Code. This particular table is dealing with pile-supported structures. So there's a different criteria for pile-supported structures. And when you have a building that's 6,000 square foot built over area, now you're only required 3 borings for the 2014 code and 4 borings for the 2008 code. And you can see that they're basically 2 different equations moving at a different slope. So when you get to a built over area of 100,000 square feet, that's where you start to see an additional boring savings. So that's something to look forward to. This table is showing you the alternate test substitution rate for borings. So alternate tests are becoming more mainstream. I think the committee felt more comfortable increasing the criteria, the substitution rate. When I talk about cone penetrometer tests, or CPTs, those are pretty much the alternate test of use. So the provision for CPT substitution in the 2008 New York City Building Code was 2 CPTs for 1 soil boring. That's the substitution rate. But for the 2014 code, you're looking at 1.5 CPTs for 1 soil boring. So additionally, the minimum number of borings required when a substitution is proposed is 2 borings for every 10,000 square feet, or 1.5 required borings for not less than 2. So the 2014 code, 1/2 of the required borings, but not less than 2. So a quick example here, a 20,000 square foot building would require 4 borings and 14 CPTs when alternate tests are proposed for the 2008 New York City Building Code, whereas the 2014 Building Code would require 4 borings, but only, 5 borings, but only 8 CPTs. So you have to do more borings, 1 more boring for the 2014 Building Code, but the number of CPTs is significantly reduced. Another nice change here, the allowable bearing pressures of certain type 7 soils was changed or increased. Gravel and crushed rock previously had a 3 ton per square foot allowable bearing pressure. That has been increased to 6 tons per square foot. And concrete fill was previously not permitted as a structural fill, but the 2014 Building Code is going to permit it as a structural fill with an allowable bearing pressure of 3 tons per square foot. Some of the highlights to the shallow foundation section, BC 1805. This was previously called footings. This shallow foundation is a new term, an IBC term, so that's a widespread change to the building code. Chapter 18. Grade beams, a exemption was added to make explicit that grade beams are exempt from frost protection requirements. So there was often question about whether grade beams were required to bear below well, they don't really bear, but to be located below the frost line. That's not the case. Additionally, piers were relocated to the shallow foundation section. The committee felt that they are more appropriately located in this section, and it makes explicit that pile load tests don't apply to pier foundations. The damp proofing and waterproofing section was significantly amended. The prescriptive requirements from its legacy text from the 2008 code and from the 68 code was removed. Previously they had very, I don't want to say outdated, maybe they were outdated provisions, and the committee felt as though there are a lot more options out there and that it should be more of a performance-based section, so that was removed. With regard to deep foundations, this is a new term also. Previously, piles, the section was pile foundations, and now we're calling it deep foundations. This is consistent with the International Building Code. So micropiles, we have a new definition for micropiles, or amended definition. Micropile is a drilled and grouted deep foundation element with a diameter that measures between 5 and 14 inches that develops its load-carrying capacity by means of a bond zone in soil. So previously, a cased concrete pile had a minimum diameter of 8 inches, so this is making clear that a diameter less than 8 inches is acceptable for micropiles. Some highlights of this section 1810.8, obviously I've gone over the diameter. One thing to keep in mind is that the design shall exclude end bearing. This is just a friction pile. The load carrying capacity is developed in a pressure grouted bond zone in a class 4 or better soil. So silt type soils, class 5 soils, this particular type of pile is not suitable for that class of soil. Additionally, axial compression load tests are not required for loads less than 20 tons for micropiles. Deep foundations, again, helical piles. A new definition was added. This is the helical piles are defined as a manufactured deep foundation steel element consisting of a shaft and one or more helical bearing plates, helices, screwed into the ground by application of torque on the shaft. So some of the highlights of section 1812, one thing to keep in mind is that helical piles require approval in accordance with 28113.2. So the takeaway is that all helical piles are not created equal, and there is a helical pile buildings bulletin which will be amended to reflect the fact that there were some changes in the building code, but it does accurately reflect how a helical pile is approved and accepted by the department. So if you can see the lower picture, the one in the middle, this particular helical pile has a sticker on it that says ICC ES Legacy Report number 95048. So this particular helical pile was evaluated and approved by ICC, and so that particular pile is acceptable for use in New York City. I would look to the building code, the buildings bulletin, which will be revised to verify exactly how helical piles are considered and deemed acceptable. Helical piles are acceptable for 30 tons maximum axial tension and compressive load. They cannot exceed 30 tons. They are acceptable for 3 tons maximum lateral capacity, and the installations are subject to special inspections, which Gus will cover shortly. Splices. So just an excerpt from this splicing section, it states that in all cases, splices shall develop at least 50% of the capacity of the pile in bending. Now, this section hasn't really changed except for an exception for caissons, specifically caisson core beams. The committee felt as though caisson core beams shouldn't necessarily have to meet the requirements above because the loads in the caisson core beam wouldn't get this high. So there's an exception for caisson core beams that state that the splices should be designed for the lesser of 50% of the capacity of the core in bending, or 2 times the design bending moment carried by the core at the location of the splice. So this should result in a savings for splicing. Keep in mind that core splices must not be within 2 caisson diameters of any splice in the casing. The 2008 New York City Building Code was a little scant on the number of lateral load tests, just on specifying the number. There was no guidance on how many lateral load tests are required when lateral loads exceed 1 ton. So if the lateral loads exceed 1 ton, then lateral load tests are required. Okay. So for a single pile or capacity, a minimum of 2 piles must be tested for every area of similar subsurface condition. For multiple pile types or capacities, load test requirements of 1808.4 shall apply separately and distinctly to each different type of capacity or pile or equipment used or method of installation. So the takeaway from this is that if you're using different types of piles, you're in different conditions, then probably more pile load tests are required. There was a new table added which kind of consolidated all of the allowable stresses for materials used in piles. This is consistent with IBC, and it's good because all of the maximum allowable stresses are now located in one table. With regard to liquefaction, as Gus previously mentioned, the building code now adopts ASCE 710 for seismic provisions. Because liquefaction is primarily a seismic phenomenon, we adopted ASCE 710 for this particular section. So in keeping with that, this particular section was amended, and all of the screening and analysis requirements of ASCE 710 were incorporated in this section. One thing to note is that per ASCE 710, section 11.8.3, the potential for liquefaction screening must be evaluated for site peak ground accelerations consistent with the maximum considered earthquake peak ground acceleration. So this is going to result in screening to a higher acceleration than previously in the 2008 New York City Building Code. Section 1813.1 was amended to clarify that clays, silts, and clay silts below the water table with a plasticity index less than 20 have to be considered for liquefaction potential. And as for 1813.2, site-specific analysis, it was clarified that borings used to evaluate liquefaction have to be performed in accordance with ASTM D6066. Further on liquefaction, BC 1813.2.1, peak ground accelerations. So for consistency with ASCE 710, a new table was added. This table 1813.2.1 shows all of the values of the maximum considered earthquake geometric mean, peak ground accelerations adjusted for site class effects. And additionally, foundation design and analysis, definitions were improved and required relationships were changed so that the cyclical resistance ratio and the cyclical stress ratio reflect ASCE 710. Lastly, the liquefaction assessment diagram was modified for consistency with ASCE 710 and ease of use. As for the underpinning and support of adjacent structures, this section was, the title was changed to infuse adjacent, the general scoping provisions were expanded to include protection of property not containing structures. So if you're supporting excavation adjacent to a piece of property that doesn't necessarily have a building on it, you're required to protect that property so the loss of ground doesn't result in the sidewalk sinking or cracking or things like that. Additionally, the underpinning and bracing section 1814.11 was modified to clarify that underpinning piers, walls, piles, and footings are designed as permanent structural elements because they will remain in place and carry loads for the duration of that structure. And lastly, this section clarified that underpinning foundations and structures shall be designed to account for lateral pressures exerted on the underpinning. So when the underpinning is in place, lateral loads on the inboard side of that wall could result in an unstable situation if the building is not properly braced. So I think that's it. It is. So at this time, we're going to take a 20-minute break. And so now it is 10 past, so we'll come back at 3:30.